The reflexive, symmetric, and transitive property are properties of congruence you will use in this lesson. The reflexive property states that a value is equal to itself. For example, segment AB is congruent to segment AB. The symmetric property says we can interchange the sides of an equation, and the equation is still a true statement. For example, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. The transitive property tells us that if we have two things that are equal to each other, and the second thing is equal to the third thing, then the first thing is also equal to the third thing. For example, if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Now we are going to go over the angle addition postulate. For an example of the angle addition postulate is if point B is in the interior of AOC, then AOB plus BOC is equal to the measure of angle AOC. Now we are going to use the angle addition postulate and a proof. So your first statement is angle 1 is equal to angle 3 because it's your given statement. Next, we know that angle 2 is equal to angle 2 because of the reflexive property, and the reflexive property states that the value is equal to itself. Next, we could say that angle 1 plus angle 2 is equal to angle AEC, and angle 3 plus angle 2 is equal to angle DEB. Now we could say this because of the addition property of equality. And this is kind of where your angle addition postulate comes into play. Lastly, we could say that the measurement of angle AEC is equal to the measurement of angle DEB, and we know this because of substitution. Now we're going to talk about the vertical angles theorem. The vertical angles theorem says that vertical angles are congruent. For example, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Now we're going to try proof using the vertical angle theorem. So your first statement will be your given statement, which is angle 1 is congruent to angle 4, and your reason will be given. Next, we know that angle 4 is vertical bound from angle 2. Therefore, using the vertical angles theorem, we know that angle 4 is congruent to angle 2. And the reason will be vertical angles are congruent. Next, you know that angle 1 is congruent to angle 2 because of the transitive property of congruence. Now we know that angle 1 and angle 3 are vertical, therefore we know that angle 1 is congruent to angle 3 because vertical angles are congruent. And lastly, we know that angle 2 is congruent to angle 3 because of the transitive property of congruence. Now we're going to talk about the segment addition postulate. An example of this is if 3 points A, B, and C are collinear and B is in between A and C, then segment AB plus segment BC is equal to segment AC. Now we're going to use segment addition postulates in a proof. The first statement is segment AB is congruent to segment CD because it's a given statement. Next, we know that segment BC is congruent to segment BC because of the reflexive property, which states that the value is equal to itself. Now, we know that segment AB is equal to segment CD because congruent segments have equal length. Now, using the addition property of equality, we know that segment AB plus segment BC is equal to segment CD plus segment BC. And using the segment addition postulate, we could say that segment AB plus segment BC is equal to AC, and that segment BC plus segment CD is equal to BD. Using with the segment addition postulate. Now, using the substitution property, we could say that segment AC is equal to segment BD. And lastly, segment AC is congruent to segment BD because we know this because equal segments have congruent lengths.
Today we'll be learning about the Pythagorean Theorem. The Pythagorean Theorem is if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if the triangle is a right triangle, the sides A and B, which are the legs, are squared, are equal to the hypotenuse, which is across from the right angle. So this is represented by the equation a squared plus b squared equals c squared. The next theorem is the converse of the Pythagorean theorem. The converse is if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the hypotenuse, then the triangle is a right triangle. So it goes if a squared plus b squared equals c squared is true, then the triangle is a right triangle. Next is an example of the Pythagorean theorem. This question tells us to find x, which is finding the hypotenuse. So to solve this problem, we have to use the equation a squared plus b squared equals c squared. So a and b, the variables a and b, are legs, and it doesn't matter what you use. This could be a, this could be b, or this could be b, and this could be a. So these are the legs. So we have to replace the variable with the number. So 16 squared plus 12 squared equals c squared. We have to get the c variable alone, so then we square root this equation, and then it ends up being 256 plus 144 equals c square root. Yeah. And then it ends up being, and then if you simplify further, it ends up being 400. The square root of 400 equals c. So that's the answer. The last thing is an example of the converse of the Pythagorean theorem. So we have to prove if this statement, if this triangle is a right triangle, is true. So to solve it, first we have to start with the equation a squared plus b squared equals c squared. We have all the variables, so all I have to do is plug in the numbers. So 2 squared plus 4 squared equals 5 squared. If you simplify it, 4 plus 16 equals 25. If you simplify it even further, it would be 20 equals 25. We can see that 20 and equals does not equal 25, so this statement would be false. And a way for this to be true is if this side was 3 instead, and we can prove this with the same equation, a squared plus b squared equals c squared, by plugging it in. So 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. 25 equals